All right, let's check back in now that you had a minute to discuss number 1 and number 2 with your partner. I got 15 units squared for A, 12 units squared for B, and 42 units squared for C. We should label area with units squared. Okay, it's not just inches or centimeters. It would be inches or centimeters squared because we're dealing with area. Can anyone tell me what they wrote for their area equation for number 2? Length times width. Right? Length times width. Or the side times the side. Oops. Width. Oops. Length times width. And again, your answer should be units squared, the label, because we're talking about area. Are we good with number 1 and number 2? Area of a rectangle. We're okay with that. You've heard this before? Give me a thumbs up if you've heard this before. Yay! Fantastic. Let's look at 3 where we add in some trigonometry. You're excited. I know you are. All right. What if we don't know the side lengths? But what if I know maybe the diagonal and an angle? Let's do A together. I know the diagonal. Okay, in case you didn't know, this is a diagonal. If you didn't know that, I might label that. You're going to see that language come up. Diagonal. And a diagonal is 9.5 units. I know that this angle is 90 because we're in a rectangle, and a rectangle has 4 90-degree angles. We know that. So then if I look at it, what's going to happen here in this triangle is it's actually going to be a 30, 60, 90. Uh-oh, that seems special. That seems special. How can I find the side across from the 30 if I know the hypotenuse or the diagonal here? Got to go back to those relationships. Did we forget? Remember, this is always x. This is 2 times your x. This is x times root 3. So to go backwards, I would take 9.5 and do what? Divide by 2. I'm going to divide it by 2. And this is really going to be about 4.75 units. I'm going to find the length now, and I'm going to write it as 4.5 times root 3 using that special right relationship. And again, my goal is to find the area. So now I know the length and the width. You're going to need your calculator. 4.75 root 3 times 4.75. You're going to type that all in with multiplication. Let's see what your area is. Get somewhere around 39. 39 units squared. No? You would do 4.75 times 4.75 times the square root of 3. Again, if you had done 4.75, times root 3, you would have to either put a parentheses or arrow out of that root. Don't put times 4.75 under it again. Maybe that was our mistake. Was the root parentheses? Okay. Great. Let's try B now. Let's try B. In B, we're given the diagonal. We're given an angle. But I need to find the length and the width. The length and the width to find the area. I want you to turn and talk with your partner. I'll give you a hint. You're going to use a trig ratio. Which one should you set up? Turn and talk with your partner. You're going to cross multiply and solve for 7.1. Or sorry, you're going to solve for x using 7.1. Again, you should be practicing this on your paper. We've had a lot of tests on this. It's going to keep coming up. In your calculator, you would end up typing in the sign of 64.6 times 7.1. We should get x is about 6.41. Do I need to do more trig? How could I find the width? Pythag. Now we're going to do Pythag. Pythag. Who can remind us what Pythag theorem is? Great, let's do it. A squared plus b squared equals c squared. Which one are we missing? A, B, or C? We're missing one of the legs. We're missing A or B. That just impacts where you put 7.1. So I know it's 6.41 squared. That's one of the legs. I don't know the other one. And I do know the hypotenuse, C, is 7.1. So let's solve. Again, our goal is to get to the area. So we need the length and the width to find the area. Last step would be do 6.41 times 3.05 to get your area of about 19 point. I multiplied afterwards. I got the two sides and then I multiplied. 3.05. I squared this number and I squared this number. So then I did 50.41 minus 41.08 and then I square rooted that. Let's walk through it. All right, to solve Pythag theorem, we're going to square each number first. Then I'm going to minus 4.08 from both sides because I want to get the variable alone. Then I got, let's just double check, 50.41 minus 41.08, about 9.33. And I can't leave it as y squared. That's not my side. I have to square root. So maybe we forgot the square rooting step. Oops, don't divide it by 2. Square root. And I got about 3.05. Does that clear some things up? Pythag theorem. Again, once I got that, I just multiplied my length times my width. So I did 3.05 times 6.41. Got an area of 19.55 units squared. Wow, that's rectangles. Questions? Now let's find the area of squares. Obviously in A, you can count. B, you're going to have to use some trig or a special right triangle. Try it now with your partner. Then I want you to write the area formula or equation. We're going to stop after 5. That might help. Recalling the angles. Keep working on part B. Let's see if you can figure out the side. 5.8. Remember, these two should be congruent. So I just have to do trig one time. Opposite hypotenuse. I'm going to set up the sign. The sine of 45 equals unknown over 8.2. So then when I cross multiply, it's going to be 8.2 times the sine of 45 equals x. When we do that in our calculator, we should get About 5.8. Again, these two sides are congruent, so I don't need to do any more trig to find the other side. Now I'm just going to do 5.8 times 5.8 to get the area of about 33.64 units squared. How do we feel about a square? There was some trig. It ended up being a special right triangle, or you could just use sine. Questions?
I used .79 instead.
Okay. Then it'd be a little off.
5.2.
Yeah.
That's okay, right?
That's fine. Can anyone tell me the area formula for a square? No? Side squared? Yeah, it's side times the side. And it's the same number, so I could say side squared or s squared. Yeah? That would be the formula because it's the same. A square has all equal sides. We're okay with that? Different than a rectangle. Okay, let's look at 6 together. You're going to see a problem like 6 on concept checks, on the test. This time we start with the area. The area of the square is 121 centimeters squared. How could I tell it was the area from just the label? It has the power of 2. What is the length of one of those sides? How did you do that? The square root. If you're not sure what that's called, write it down. The square root. We're going to square root the area and get 11. And I could always check my work. 11 times 11 equals 121. That's the area of a square. 7 says the area of the rectangle. Uh-oh. One of the lengths is 5 centimeters. What is the length of the other side? If you're not sure, draw a picture. The area is 16 centimeters squared. One length is 5, and we don't know the other one. How are we going to find the other dimension? What are we going to do? We need to work backwards. Remember, the area formula for a rectangle is length times width. Yeah, let's do 16 divided by 5 to work backwards to the other one. It's going to be a decimal, 3.2. So the other side is 3.2 centimeters. You're going to see problems like 6 and 7 on tests, concept checks, where it's words. Ready? Let's divide this in half. We're going to go over the properties of rectangles and squares and then their areas. So, a rectangle. A rectangle. Make a sketch of a rectangle. And then we'll talk about the squares. Sketch of a square. We're going to talk about the properties of these two shapes. 90. So put 90-degree angle symbols. All the angles in a rectangle are 90 degrees. What's the relationship of the side lengths? 2 pairs of equals? Yeah, so this is congruent to this one. This is congruent to this one. Notice the difference in the congruent marks? Something else we can say. These are parallel. Uh-oh, remember that? And these are parallel. Okay? Good things to know about rectangles. And today we looked at the area equation, and it's length times width. And again, parallel lines comes up. You might have to use that in a problem. Let's talk about a square. What are all the angles in a square? 90. What's unique about all the sides of a square? They're all equal. So here's a question for you. Is a square a rectangle or is rectangle a square? A square is a rectangle. But a rectangle is not a square. Why? Why is a rectangle not a square?
not all the sides are
Because not all the sides are equal.
Seems like a trick question.
It's not a trick question. It's just using the vocabulary. Let's talk about the area equation. The area, we said, was the side length times the side length, or we could write it as side squared. As a little side note, again, trigonometry came up today, so we can use trig to solve for unknown sides. SOHCAHTOA, in case you forgot it. If you did forget it, there's always that wonderful song. Oh man. And number 1, we used Pythag theorem to solve for the unknown length. Then found the area. And number 2, we divided it up. It's called a composite area. I had a square plus a rectangle. And in number 3, a special right triangle appeared. Wow. 9 times 9 is 81 meters squared. Questions? Questions?